Hello, it's me. I was wondering if you wanted another lesson about science. We're in textbook page 364 to 365. Let's get started with the lesson. Okay, Adele mode off. Let's start off with a little quiz. Surface currents are mainly driven or made by A. Sea breeze, B. Land breeze, C. Global winds, or D. Jet streams. 5, 4, 3, 2, 1. I'm going to get rid of land breeze because that is when we have air moving from the land to the ocean or sea, whatever body of water, because there's a temperature difference between the land and the sea. I'm also going to get rid of jet streams because jet streams are pretty high up in the atmosphere. So I think they're too high to affect surface currents. All right, so then correct answer is C, global winds. Remember, a sea breeze is basically the opposite of a land breeze. It's when you have air moving from the warm water back to the cold land. All right, so today we are going to talk about factors that affect surface currents. Remember, we learned about currents yesterday. Listen, if you're going to know one thing about me, I really love a good looping GIF. So I'm just going to stare at this GIF for 2 seconds before we go in because I find it relaxing. All right, relaxation over. So again, surface currents are currents that move water on the surface of the ocean. So it's basically exactly what it sounds like. Okay, so this is not actually part of the lesson, but I want to share it with you. So when I was in college, I decided that I'm going to take a class about marine biology because I've always been interested in marine biology and I thought it'd be super cool. I thought I would spend an entire lesson learning about whales and porpoises and cute little seals that when they met me, they automatically would want to be my friend. And I'm like, yeah, I can do this. Well, guess what? We spent 1 week, and since it was a Monday, Wednesday, Friday class, it was only actually 3 days learning about marine mammals, which is what whales, porpoises, and sea lions are. The rest of the time, we spent learning about surface currents, like you and I are learning right now, and water chemistry. And I was just like, why? Oh, man, it was like 5 weeks of really, really difficult stuff. But the point is, if you are interested in marine biology, if you are interested about, I don't know, anything to do with snorkeling, boats, if you are interested in becoming a marine biologist when you're older, you really do have to understand both water chemistry and surface current. So if you're like, I don't get why we're learning about this right now, it's part of a bigger picture. So I get it. It's a little tough. Oh, we'll suffer together, but it's going to help us become better scientists in the long run. All right, so let's go back and review a little bit from a couple lessons ago about wind belts. So wind belts are a type of global winds, and they are not stationary, meaning they don't stay in one place, and they can move from month to month. Okay, and how do we get wind belts? Well, we get them from unequal heating of Earth and Earth's rotation. So please remember that the sun, or specifically the sunlight, doesn't hit Earth the same way. So we have direct and indirect sunlight. Remember I said direct is on target and indirect would be like on the target but not dead bullseye. So the poles have indirect lighting, that's why they're a little bit colder, while the equator has direct lighting, and that's why it's usually some of the hottest parts of Earth. Okay, so moving on to factors that affect surface currents. So this is new. We're going to have wind belts affect surface currents. We're also going to have unequal heating of the sun's on the sun's rays on Earth also affect surface currents. And of course the Earth's rotation, because we can't neglect that. We can't forget about that. So we're going to have a pattern develop, or patterns develop. So what's going to happen is warm currents are going to move away from the equator. So this is a diagram from your textbook. And in red, these are going to be the warm currents, and they're moving away from the equator. If I could draw the equator, I'd probably draw it like kind of right through the tip of, or the top of South Africa. All right, so then if warm currents are moving away from the equator, what do you think cold currents are going to do? I'm going to give you a hint. They're going to go the opposite. So cold currents are going to move towards the equator, and these are represented in the blue arrows in our diagram, okay? Think red hot, ice, or blue cold, icy cold. All right, so I want you to look at the picture on page 365 again. What are you noticing about the shape of the arrows? Take a minute to think about it. Hopefully you realize that they're not a straight arrow, but they're curved, okay? And this is because of the Coriolis effect. Do you remember that? Well, if you don't, I'm going to review it. So the Coriolis effect is due to the Earth's rotation, and because the Earth is rotating, it's actually going to curve the winds. Well, guess what? This is also going to cause the currents to curve. And that's why in that picture, we don't see straight lines, we see these curved arrows. So this is going to result in the northern hemisphere will have currents that curve to the right. And what do you think is going to happen in the southern hemisphere? It's going to be the opposite. So in the southern hemisphere, the currents are going to curve to the, what do you think? Hopefully you say left. All right, we keep talking about water flowing. Well, I'm done, and I want to know, how do I make the currents stop? Well, the currents are going to continue to flow as long as they are pushed by the wind. But if they hit land, like a continent or an island, they're going to have to find a new path. So when they hit land, they will stop. So let me give you an example. Let's pretend it's a really nice summer day, and I set up a slip and slide on a hill. I'm going to take my hose, and I'm going to spray water at the top of the slip and slide. And that water is going to follow the path down the slip and slide, and it's almost going to be like a fake or artificial river that I made. Well, let's just say I'm feeling kind of evil and I put a ginormous rock or boulder in the middle of the slip and slide. Well, that's going to stop the water. And now the water is going to have to find a new path. So the water is probably going to go off the slip and slide into the grass. So that's the same way as currents when they hit land. They're going to have to find a new path. All right, let's end with a quiz. Which factor does not affect surface currents? Is it A, unequal heating of Earth, B, Earth's position in the solar system, C, Earth's rotation, or D, wind belts? 5, 4, 3, 2, 1. I'm going to get rid of Earth's rotation because that does affect surface currents. Remember, Earth's rotation creates the Coriolis effect, which will make curved currents. I'm also going to get rid of wind belts because that's one of the first things that we learned in this lesson, that wind belts affect surface currents. So the correct answer is B, Earth's position in the solar system. I don't really talk about this in this lesson, so if I don't talk about it, it's usually not the answer. All right, guys, that is it for today, and I will see you tomorrow.